Today on Ask the Trainer, a question comes in from Sacramento, California, and they ask, actually, it's more of a statement. They said, we had a broken mainline yesterday, but it didn't shut down. What went wrong? A couple of things could have gone wrong. So this can be a multi-part explanation. So the first one we want to check is, was your controller online? What did it have communication? So to do that, let's jump into Base Manager. So I've already logged into Base Manager with my username and password, and I'm on the maps page. Well, the thing I'm looking for is in the lower left corner where it says controller clock 71 and clock 72. That's green. The controller is idle. It's in its green means go, or it's ready to go. If it was gray, the controller would be offline, and it could be for a couple of reasons. It could be that the controller doesn't have a good communication method, that the cell modem is down or Wi-Fi or whatever your networking connection is down, or it could be that the controller is not powered up and it's not actively working. So with that resolved, so that wasn't the issue with this one. So the other thing to look at is maybe the limits in Base Manager are not accurate. So I'm going to assume that the devices are assigned and set up correctly, that you've assigned your flow meter, that you've assigned your master valve, that you've got the right K value in there for those, that those are dialed in. So if that's not the case, that's another dive into that one. So we're going to go in the flow setup and then open the control points. So we're going to look at this first control point. I'll open that one up and then click Edit. And the first thing we notice is that there's a design flow of 120 GPM set. That's good. The high flow limit is set for 130 GPM, and they've clicked shutdown. So if shutdown is not selected, what would happen is if it's flowing higher than the 130 high flow limit, it won't shut down. That's obvious, but it will send an alert. Shutdown is always a good idea for high flow limit because it's probably a catastrophic mainline failure, and I want to have that shut down. If there were pressure limits, you'd want those set here and decide if you want to shut down or just get an alert. So that was it. When I was mentioning earlier on that I'm assuming they had their devices set up correctly, well, actually having the correct K value in here is critical because the K value is going to translate those pulses into actual GPM. Because if it's so many pulses and it's a 1-inch flow sensor, it'll say that's 20 gallons a minute. But if it's pulses through a 2-inch flow sensor, it'll say, well, that's 107 gallons a minute. So we need to make sure that the K value is accurate for your flow device that you're using. And the other thing you want to look at is your master valve truly a normally open or is it normally closed? So we want to make sure that those are accurate. Again, I'm assuming you've done that correctly. Get out of this one. We don't need to save this. So I'm going to cancel that one. The other thing to look at is the administration side of this one. So I'm going to go to the menu and go to administration. And then one more time, I'm going to open up administration. This opens up a new tab in an entirely different menu. And this is about the users and the user interface, the information they're going to get out of this system. So I'm going to go to my user info. And this is me as a user. This is my username. I'm a company admin. But here's the important stuff, right? I'm allowing a text alert and email alerts. I've got my phone number. I've got the information for my cell provider. So I got to have my information set up for my email and my text if I want to get messages about what's going on with my system. That has to be set up. The other thing is right here, it says disable all alerts. Well, oh, look at this. Disable all alerts is shut off on this one. So if I want any alerts coming into this one, I have to allow all alerts. That's a critical mistake I've made on this one. And then I can also select the time of day that I'm going to allow the alert. So if I didn't allow them at all, or if I only allow them at certain times of day, it might determine when I get my alert. The other thing to look at is the alert subscription. So I'm going to go to alerts and report subscriptions and open up just alert subscriptions. So this is going to decide for this particular controller, do I want all alerts on or all alerts off? Well, none of them are on, so I definitely want to turn them all on. Now, every single alert will come through. Now, if you decide later on that you're getting too many alerts, you might turn off the low level or the low priority alerts and actually shut those off. I'd recommend starting with all the alerts on because you don't want to miss out on some that may be high level to you, but low level to our engineers when they set that up. So if you aren't getting alerts, or if your master valve isn't reacting in instances when you would want it to, make sure that the communication is good, that you have a rock solid communication method from your controller back to base manager. Check those limits in base manager, and make sure the device is set up correctly. Make sure the admin user, under admin, that your user has the correct contact methods. Is it email? Is it text? Is he getting it once a day? Is it getting it 24 hours a day? And then make sure you've got the alert subscription set up. So those are 5 things, or those are 4 things to check to make sure that that's working right for you. So the second question for Ask the Trainer today comes from Doug in Naples, Florida. And he asked, what's the difference between a multimeter and a milliamp clamp? Well, I really like tools, so this is right up my alley. So I'm going to switch cameras so we can take a look at them. This first device is a milliamp clamp. It's got the clamp portion in here, and it's got a dial. And on the dial, we have resistance, voltage for DC and AC. I have AC amps, milliamps, and off. On a volt ohm meter or a multimeter, depends on, it's the same difference. We've got voltage for AC and DC. We've got resistance, a diode check, and if you add additional sensors, you can do other things. So the big difference between this one is this will not work for amperage checking. This will work for amperage. So that's the biggest difference. So let's just first talk about where you might use the milliamp clamp. So you're going to use a milliamp clamp primarily on 2-wire systems. In that case, you're going to set the meter to AC, set the meter to AC amps, which is the A with the wave sign on it. And we are primarily going to use this as a non-invasive way to check for an overcurrent. So in that case, we'd come out to the field and clamp that around one side of the 2-wire path, and then actually get a reading as far as what we have. So this would tell us the amperage draw that would be downstream of this one. So this will help us pinpoint an overcurrent. And if you want to know about overcurrent troubleshooting, you will find that in another video, which I'll put in the show notes. So that's primarily what this is used for. A volt ohm meter can be used on conventional or 2-wire. I cut my teeth when I was a contractor on conventional wire systems, and this is definitely the tool working on conventional. So one of the common things you're going to use it for is on testing solenoids, right? So if we can set this to resistance, which is the horseshoe looking object. What's the correct name on that? Is it omega, alpha? I forget. We'll have to look that up. So I'm going to check the solenoid. I'm going to come and just test these 2 leads of the solenoid. And we can see that I have about 24, 25 ohms of resistance for this known good solenoid. And that's about what Hunter solenoids read without the wire path in there. Rainbird solenoids read different. Toro solenoids read something else. But this is going to tell me that I have a good continuity between this one. I can also use this to check fuses. I can put this on either end of a fuse. Even though a fuse looks good, it may be burned out. So this is about resistance on this one. So the other thing we can use this for is checking voltage. So I've got a 9-volt battery we're going to check. So I'm going to turn it to volts DC. And I'm going to put it on the positive and the negative side. And let's see what we come up with. Well, that battery is actually not bad. It's got 8.3 volts in it, considering it's a 9-volt battery. So that's pretty good. So I could check AC volts or DC volts. So this would be great if you're working on your truck, if you want to verify the power supply coming into a controller. Okay, so this is mainly about resistance and power. Well, let's come back to the milliamp clamp. We said earlier the milliamp clamp has this volts. So I can do the same thing with this controller. All I just need, with this device, I just need another set of leads. So, and this device does come with an extra set of leads. So I can plug these leads in here and measure the voltage on this battery. I can also use the same device and measure resistance right there. So I can measure resistance, voltage, and amperage with this device. This device is just for voltage and resistance. So here's my plug for these devices. A milliamp clamp or a volt-o-meter was good for checking resistance and voltage. So if you have a conventional wire system, this is definitely more attainable. It's you can get them for a relatively cheap price. A milliamp clamp is going to be a good chunk more. It's $200 to $300 for this device, but I can check resistance, voltage, and I can check amperage on 2-wire systems. So if you have a 2-wire system, this is definitely the best tool to have. If you have conventional, this will do it for you. Have a question for me? Click the link in the description and go to hydropoint.com/askthetrainer to submit your question.